So welcome to everyone to the RePicture STEM summer program. This is our first week of the panelists. Every Thursday, we will be having a panel discussion. We're really excited to have our first one. And before I get started on that, just a reminder for the students for next week, we have a really interesting week planned for next week. It's going to be about career exploration and really helping you, whether you're a high school student trying to figure out, what STEM career or what career in general you might want, but even for those college students, really digging deeper into your major and what you can actually do with your majors. So it's going to be a great sessions for everyone. So with that, I'm going to share my screen.
And while Lynn is figuring out how to share her screen, I just wanted to say I'm really excited to have all of you esteemed panelists with us today. And something we talked about last week with the students is the idea that your friends are a really important part of your network. So I did want to share that Allison is a friend of mine, and we actually met when we first started out in our career. So like our very first job out of college or whatever. And that was like quite a while ago now. I won't say when, but Allison has just been like an incredible support, and she's been reading for RePicture since day one. So I'm really excited to have Allison here with us and to meet and get to know all of our panelists who I'm going to be learning from and meeting alongside all of our participants today. And I also wanted to give a little bit more about what is planned for next week. Lynn mentioned we're going to be diving into career discovery and self-development, and I'll be leading a session on that on Monday. And then on Tuesday, I'll lead another session on using RePicture as a tool for career discovery. And then on Wednesday, Lynn will kind of delve in and give you some more details about what to expect in the next several weeks and what all we have planned. And then Thursday, again, we have another panel discussion on designing communities. And on Friday, Jerry will lead our social with a really great game. So looking forward to all that. And looks like Lynn's got her screen up, so I'll turn it back over to Lynn.
Okay, great. Thank you very much, Elisa. So today we're going to have a little different format from future ones. Hopefully you all have gotten an email or scooped an email talking about what questions you want us to ask next week's panelists. But for this week, you're actually going to hear questions that I've developed and our team has developed. But if you have any questions for our panelists, please do a private chat or even a group chat to Jerry. And you can basically at the end, we'll have some time for questions. So I'm going to give a brief introduction to our panelists. We'll then have some questions that we'll give them about their STEM journey. And then we're going to actually do something a little unique. And then we're going to give you, the students, an opportunity to vote real time on what additional questions you want to ask. So I'd like to start with the poll, actually, and just to get a sense for where people are. And our poll is about how much do you know about the actual work of scientists and engineers? Do you know many scientists and engineers and what they do? Some scientists and engineers, what they do. Maybe you know a little about what some scientists and engineers do, or you don't know what scientists and engineers do. So if we could, just to help us kind of get a sense. Okay, so we will give you one more second. Looks like it's stabilized. So let's we'll share the results here, and you'll see that, which is good. It's basically people know what some scientists and engineers do, and that's great. And this upcoming 6 weeks, you're going to learn even more. So hopefully at the end of the 6 weeks, you'll know what many different scientists and engineers do. And these panel discussions are a good way to get to know. So I'm going to introduce the panelists, but if you want to learn more about some of the panelists, you can go to the RePicture website and just type their names, and you can actually learn more than the quick introductions I'm going to do right now. And our first introduction is Dr. Erika Dillard. We're so excited to have Dr. Dillard. She has a BS in neurobiology and neuroscience. She also has a medical degree in medicine and a PhD in microbiology and immunology. So she's a very busy lady. But I also know a lot of students are often interested in being entrepreneurs. And what's really interesting with Dr. Dillard is she also is the founder of a new startup, Pop Check Technology. So I think it's gonna be really interesting to hear from her. We're also really excited to have Jonathan Tavarez. He is has a bachelor's in civil engineering and master's in structural engineering. He works for the American Institute of Steel Construction, who's been a really great partner for us. And one of the things Jonathan does a lot, but one of the things he does is he's part of what they call the Steel Solutions Center, which I think is a great name of a program. And what he's doing is really, bottom line, is helping making our buildings safer. So typically when you go into a building, you don't think about whether it's safe. And that's because of the work that Jonathan and the people he work with does. We're excited to have Joe Mitchell. Joe is a certified trainer for North American Board of Certified Energy Professionals. When I asked Joe as far as how he got his education, he talked about his time in the Army was really informative to him. So you can learn all kinds of things from all different places, but he's now a professor teaching green energy. He's also works with Little USA Solar, another partner of our program, and he's in the process of designing and installing a solar farm down in Alabama. So we're really excited to have Joe and thankful. And then our last one is Allison Andrews. Allison, who Lisa just talked about, as far as those friendships, there's networking. She and Elisa work together as floodplain managers. Allison has a BS in civil engineering, also an MBA. She's an associate vice president at a large consulting firm. And again, she does really important work. I mean, all the work that everyone's doing is really important, but disaster planning and response, just really important work. So again, we're really excited to have all these panelists today. So I'm going to stop sharing so that you all can hopefully see our panelists. And so what we're going to do today is I'm going to start with some questions, and again, we're going to then open it up to the students. But for the panelists, this week our students have been learning about kind of telling their story, their STEM journey. And so what we want to do is just start with a question about having you talk about your STEM journey. So where did you, there are really just an unlimited number of opportunities of where things come from. So could you just tell us a little about, how you got to where you are and what do you like about your current job? So Erika, I'm going to start with you to just kind of talk about your STEM journey.
Yeah, so great question. I had to kind of pull back in the memory about how I came to even be interested in medicine so many years ago. But, I've always been someone who just really enjoyed working with my hands and building things out of just stuff that I would find around the house. And so always enjoyed nature, being outside, observing life around me. So it was kind of almost fitting, I think, that, naturally I had an affinity for science and engineering. And I bounced around a lot as a kid, just as a result of my mom working with the US Army. So we eventually landed in a city called Huntsville, Alabama, which is a hub basically for engineering, specifically aerospace engineering, because NASA is located there. And there's a huge military base there with a big focus on missile defense. So my exposure to STEM, I would say in that aspect, was kind of unpreventable. I left Alabama, and went to Nashville, where I was a student at Vanderbilt, originally majoring in math and with a minor in Spanish. But halfway kind of through my undergraduate education, I decided to just take a neuroscience course, which just that one course really changed my trajectory, I would say. of my focus for quite a while after that. It was, really that one course. I would say I'm very grateful that I even had the opportunity to take that course. In a liberal arts kind of education, we had a lot of flexibility of taking things outside of our major. So I really was very fortunate to have been able to take that course during undergrad. And eventually from that went on to medical school and doing training in neurosurgery. But it's interesting also that things really come full circle. Just in general, life has a way of just, doing that allows you to fall back into those opportunities that allow you to make the most of your kind of like your inherent gifts and your passions. So, during neurosurgery, a lot of things happened, while I was doing my training, but I eventually found, an opportunity laid in my lap, basically through an email about a program that was being developed in Memphis that was taking people who had science backgrounds, whether it's engineering, math, science, medicine, and teaching them how to commercialize intellectual property. So how to develop new technologies and take those technologies and spin them out into companies that are marketable, so that whatever field I'm in, for instance, I'm in healthcare, so that patients will have access to those new devices or treatments. So that's really, I would say, kind of like a shortened view of my journey, but definitely, builds everything that I'm doing really builds upon what experiences I've had up until this point as a physician scientist, and now as a physician entrepreneur.
Great, that's great. And I think it kind of emphasizes one of the things we've been experiencing and talking about students are experiencing. It's so much of your career and so many little happenstance, right? You happen to take that class, you found a passion for it, and you happen to read that email that gave you that opportunity. So, really for the students to really just take advantage of everything that's out there. So thanks, Erika. Joe, I know your journey's been a little different. Do you want to tell people your journey of how you got to where you are?
Yes, I will. Thank you for having me. You said I was in the Army. I need to correct you. I was in the U.S. Air Force. There's a big difference.
Sorry.
That's a joke. If you served in the armed forces at all, I'm proud of you. I was in electronics in the Air Force, specifically communications. And that opened, I grew up in a very rural place. That opened my eyes to, matter of fact, my last 2 years I spent right outside of Madrid, Spain. And that opened up my eyes to a lot of things. And as far as electrical and electronics. And then I came back from the Air Force and went to college and got a degree in electronics. And then my first job was actually with an IT company. They're not in business anymore, except it was Memorex, and they make audio things and tapes and stuff now. But we used to make, they made disk drives, and I would hang those on IBM mainframe computers. And then after that, I went to work for Tennessee Valley Authority as a network engineer and went back to school. And believe it or not, did something totally different, which I have never regretted, is I obtained a degree in economics. And so I have both sides of the plate covered. There's no use to invent anything or do anything if it's not economically feasible. And then just by happenstance, I came from that into teaching electronics at the community college that I graduated from. And then I went on and did I never did write the thesis because I didn't see the need to do it, but I did all of my master's work in technology. And then academically after that, I went to North Carolina State and did solar. So the thing that I want everyone to understand, the days, the 50s and 60s are over. You never go and just get a degree and do a job. There's always going to be change. There's always going to be new things you need to learn. And the thing that has helped me is that the fact that I always had a thirst for knowledge. And part of that, quite frankly, is growing up poor and having very few resources. So I have reinvented myself. I mean, many times, but they're still all related. For instance, I just came off of a job site where I'm building a house, a very energy efficient house, practically a zero energy house. Day before yesterday, I was installing solar. So I do electrical work, I do electronics work. I've taught electronics, I've taught electrical, I've taught building courses, I've taught Siemens mechatronics, automation. I've got into PLCs, and to prove what I'm saying, I am now working on a new company where we're going to take used tires off of your pickup truck or your car, convert those to a tire oil, and then we're going to make something called carbon black out of that process. It's a byproduct. So when I got into the energy thing about 6 or 8 years ago, and got into solar, but I also got in just a basic energy, how buildings perform. I took the HERS course and the BPI. So without being too long-winded, the thing I want everyone to understand is that life is a challenge, no matter what you do, but you have to be willing to have lifelong learning. That is so important because, like I say, the 50s and 60s are over. You don't go and work for company ABC for 40 years and get your retirement check and go home. You may be laid off, or you may see other opportunities. And so take advantage of the opportunities that you have, continue to learn, and never let a good opportunity go to waste. Jump on it and ride it. And that's what I have done. And I have had a wonderful life. Hopefully it's not near over, because I want to do this other company. I'm kind of like Colonel Sanders. I hope I've saved the best to last. So, but I've had a wonderful life, and it's all been related to some type of technology, some type of engineering. I've had a couple of businesses. So it was just, I kind of took a backwards path, I think. But I can credit all of that to the growing up poor and going to the Air Force so I could go to college. And I just took advantage of all those things that's come my way.
That's great. That's great, Joe. I appreciate that. And it just shows how important it is, like you said, for people to continue learning. Because I was just thinking, when people are just graduating college right now, what technologies are going to be available to you in the next 30 years, we can't even imagine. And I'm sure when Joe was graduating or coming out of school, he had no idea what would be available today. So just really interesting. Jonathan,
let me say one more thing, just to put a fine point on that. The year that the microprocessor was invented was the year I graduated from high school. So,
yeah, so lots changed in a career lifetime. So it's great. Yeah. Jonathan, do you want to go next?
Sure. Yeah. I guess first of all, thank you so much for having me, and welcome to all the students that are present. I feel very fortunate to be sharing this virtual stage with such impressive panelists. So thank you. So my story, I'm born and raised. I was born and raised in El Paso, Texas. That's where I actually received my bachelor's degree in civil engineering from the University of Texas at El Paso, or UTEP for short. I kind of knew that I wanted to go into either mechanical or civil engineering since I was in the 7th grade, and I can pinpoint it that specifically because so I was in band, and we took a trip from El Paso to San Antonio for a competition, and as part of that trip we ended up going to Six Flags, and I had been to a Six Flags before, but that was like I was starting to think about careers and what I was passionate about, and so I fell in love with roller coasters. For the longest time, my favorite roller coaster was the Superman Krypton coaster there in Six Flags Fiesta, Texas, and that kind of drew me down that path. Even all through high school, I would draw out my own roller coaster designs. I would lay out my own theme parks, and for the longest time, that was actually one of like my dream job, I guess. I wanted to own and operate and my own theme park and open it there in El Paso. It was going to be great. Everyone was was going to do so much good for the city, this and that. But so that of course, once you learn what is involved with doing something like that, my career goals changed. But anyway, so I ended up going to the University of Illinois at Urbana-Champaign for my master's degree. I specialized in structural engineering. Um, it was a really great experience. It was a bit of a culture shock for me. I don't know if anyone, or I don't know how many of you all kind of know where El Paso is. It's right on the border. It's a very unique little corner of the country. And so moving halfway across the country to a portion that I had never been to, really, it was a unique experience. It was a little bit scary, but it was an important growing experience. And I knew that I wanted to take myself outside of my comfort zone. You know, I had applied to UT Austin. I got in, but I had already been all over Texas, and I wanted to really take myself outside of my comfort zone and go somewhere completely different. My master's curriculum, or like that whole experience, it was very difficult for me. I questioned several times whether I belonged there. You know, after the first semester, my GPA was really low, and there were a lot of difficulties, you know, related to that. But I learned what it took to pull myself back up from my bootstraps. I got everything done, and I graduated in good standing, thank goodness. And so my first job right out of my master's, I worked for a company called AMEC Foster Wheeler, which does not exist anymore, but the division that I was working for in the Chicago suburbs, actually, we did engineering consulting work for nuclear power plants around the country and around the world. I worked there for 2 years. I learned so much. You know, just there's something about the heavy regulation that comes with the nuclear field. It teaches you really great engineering practice. You know, all the documentation involved with that, and I mean, just the humility that comes with knowing the immense power of these things. And there really is a sense of social responsibility, you know, knowing that you're going to do your very best work because, you know, lives depend on it. And so I was there for 2 years, but I knew I wanted to live and work in the city because, again, that job was out in the suburbs. I knew I wanted to be in the city in Chicago. So I started looking for jobs in Chicago and New York, and I found AISC, the American Institute of Steel Construction. So for those that may be studying civil engineering right now, you know, in your steel design class, that big manual that comes from us. So we basically, we develop the codes and standards that other engineers use to design structural steel buildings and bridges. I have loved my time there. It really gives me a bigger picture of engineering. I'm not designing singular projects, but I feel like the work that we do is impacting the industry as a whole, and I really love that.
Great. Thanks, Jonathan. And I love that going to amusement parks led to a career. So that's great. Allison, can tell us about your STEM journey.
Sure. Thanks, Lynn. I just want to echo Jonathan and saying thank you to you and Elisa. And thank you to the students for being here today and for your time exploring engineering as a career. You're already ahead of where I was at your age. I didn't start thinking about engineering as a career until late in high school. And that was because of two very influential young women teachers that I had for a calculus class. Before then, I really wasn't crazy about math even. And it was really because of these two teachers who spent extra time with me, and I applied myself, and they taught me calculus. And then they started to talk to me about a career in engineering. And that appealed to me. And the reason that it appealed to me is because I didn't know what I wanted to do. But I knew that an engineering degree would open up a lot of diverse opportunities. And so that I didn't necessarily have to pick one single path right then and there, you know, in high school, but that if I started to pursue an engineering degree and obtained an engineering degree, that there was lots of different paths that I could go down with that. So one of the things that I liked and still enjoy is being in the outdoors. I used to do stream cleanups and just liked being around streams and rivers. And so that's what led me to an interest in water resources as a discipline of civil engineering. And so that's what I studied in college, was civil engineering. And then that led to a job at Michael Baker Engineering in Alexandria, Virginia, right after school. And that's where I met Elisa. And in the world of civil engineering, they start calling streams and rivers channels, and you study open channel flow. And so that's what we were working on early on in our careers, is studying how streams and channels work, and doing hydraulic and hydrologic analyses to study flood risk analysis and floodplain mapping. And I just want to echo too what Joe was saying about being a lifelong learner. That is so important. And another thing that's been surprising about my engineering career, and also speaks to the different ways that you can apply your engineering career, is I'm also a project management instructor for my company. So I also teach, other people project management skills. And there is no better way to learn than to be a teacher. And it also feels good to give back. So that's, something else to keep in mind as you look at a career in STEM or engineering. So thank you all.
Great. Thanks, Allison. And yeah, there's so many different things you can do with STEM careers, even within that engineering. I mean, you have all STEM, they've got engineering, then even civil engineering. So it's great. So we're gonna next talk about the career track. So we have 4 career tracks, for our summer program, and we're trying to give the students some insights into these different career tracks. Don't expect at the end of this session, or even the end of the 6 weeks, you're going to know everything that's out there, because it's just unlimited number of opportunities out there. But what we want to do is really just have an opportunity for you to hear from these great panelists about some of the things they've done in these career tracks. So the first career track we're going to talk about is helping people through disaster planning and adapting to change. So we're going to do another poll. Hopefully it pops up here. And the question is going to be, how many billion-dollar disasters, and that's basically disasters that cost $1 billion each, how many billion-dollar disasters were there in 2020? How many do people think there were? So give everyone a moment to vote, and let's end the polling. And it looks like it's pretty well split, split between the 7, 15, and 22. Well, it ends up there's 22. Last year there were 22 disasters that were $1 billion of damage. And we bring this up really to show you the importance of the work in that field. And that is what we're going to ask Allison about. And that Allison is doing work in disaster response. And really just want to ask you, Allison, what are some of the different types of work that you can do in the different types of professionals that work in disaster planning and climate adaptation?
Thanks, Lynn. Yeah, it's really surprising how many different skill sets can be leveraged in disaster response. The other thing that I find interesting about disaster response is oftentimes you think about people going to the disaster and supporting there on site. And while you certainly need people to go there to help the people who have been impacted by the disaster, there's also a lot of people that are helping from afar in terms of disaster response. And so that opens up the world to a whole lot of different skill sets that are needed post-disaster, and also before a disaster, to prepare for a disaster, to make sure that it's not as disastrous as it potentially could be. And so for my own personal experience, following the 3 hurricanes that we unfortunately experienced in 2017, I leveraged my project management skills and was able to help a federal client in Washington, D.C. I was working at their office on site from Washington, D.C. again, but we were, supporting the disasters that had happened in Texas, Florida, and Puerto Rico. And what was interesting about that is while I was the person there working side by side in their offices with them, there was a whole team of people behind me that I could reach out to for support. And there was at least 50 different people, and they were working all across the country in various locations. And when I needed something, I could reach out to them and they would help with the disaster response and support as well for what our client needed. And that team was made up of all kinds of different professionals and skill sets. It included communications professionals. Those folks were putting together fact sheets and other written materials that we would later hand out to the people who had experienced the disaster, that provided helpful information that would help them recover. Working alongside those communication professionals, there was also engineers, because oftentimes those fact sheets would include technical information. And so we wanted to make sure that what we were saying was technically accurate. And so there'd be engineers who worked with the communication professionals to make sure that what we were saying was technically accurate. There was also technical writers to make sure that we were speaking with correct grammar, and that we were speaking in ways that was easy to understand. Because oftentimes with technical subjects, they can be kind of hard to understand, and you want to make sure that to an audience such as the public, you put that information in a way that's easy to digest and easy for them to understand. So we had technical writers that would help us do that. We also had graphic artists who would help us develop pictures and the layouts of different things. And then also on our team, we have separately from that team I was just talking about, we also have people who work in a call center who have degrees such as geology and geography, and they assist people who call in post-disaster and have questions about their flood maps or about flood insurance. So there's a multitude of different skill sets and professionals that can support post-disaster. That's just a few that I named.
Great, thanks, Allison. Yeah, so people may not think about, geology major doing post-disaster or writers and things like that, but there's so many people doing that. Another people might not think about is structural engineers being involved in disaster planning, mitigation. So Jonathan, can you maybe talk a little about maybe how structural engineers get involved in disaster planning?
Yeah. So first, just to give a little bit of context for those that I guess that may not know what engineers do or how engineering design works. Engineering, so we design for the highest probable worst case scenario loads, right? So I say probable because there's a whole subset of risk and reliability and the probability of certain things occurring. So you're not going to design a building, let's say in California, for the same snow loads that you would design a building in Denver, let's say. So it all depends. So engineers do design for different hazards. I think the main ones are earthquake and high winds, so hurricanes, tornadoes. But now, actually, so since 9/11, there was actually a new focus on a progressive collapse and blast design. So human-made hazards as well. So what I found interesting when this was all new to me, when I was learning about structural engineering and a subset of structural engineering, which kind of falls into earthquake engineering, is that we actually don't design buildings to remain unscathed. That would be extremely expensive for the owner to be able to have us design that. So what we do is we design buildings and other structures to I guess exhibit an acceptable amount of damage for different levels of life safety. So we design so that there is no loss of human life or loss of essential service. So for example, you're not going to design an equipment warehouse on a farm the same way that you're going to design a hospital in the middle of a city. And as structural engineers, we like to take advantage of what's called ductility and inelasticity. So every material can stretch back and forth, of course, to various degrees. On one end of the spectrum, you have, say, chalk. It's very brittle; it'll fracture really easily. On the other side of the spectrum, you have a rubber band. So steel kind of falls more along the side of a rubber band type of material. If you pull it to a certain extent, it'll return back to its original length, let's say. But if you pull it past a certain length, you start to permanently deform that rubber band, right? And so that's what we call ductility, and that starts to yield. So steel is very good at that, and we take advantage of this type of behaviors so that we can design buildings that will yield in in specific locations. So when an earthquake hits, we know that, okay, this fuse in this portion is going to yield, and that's going to help dissipate that energy so that the entire building doesn't collapse. You know, you can centralize that behavior. So that's more along the design end of things. That's more trying to prevent major damage, but structural engineers always get recruited to go on forensics and investigation trips as well. I personally haven't had the opportunity to go on this. I would love to, but whenever there is a major hurricane or an earthquake, they'll send forensics teams down there to, I guess, mainly for two reasons. One, to determine if certain structures are safe to reoccupy. You know, they'll go and they'll investigate and make sure that people can reoccupy the building safely. And number two, for research. This is a good opportunity to learn the behaviors of different types of connections. You know, what does the damage look like? What worked and what didn't work? All this is very useful data that we can come back and either tweak some of the design codes, or it'll help spur some innovation that'll increase the safety of these structures.
It's great. Thanks, Allison and Jonathan. And that kind of shows, you know, how interconnected our career tracks are, because we're just talking about disaster plan and response, climate adaptation. Another one of our career tracks is health, protecting the health of people on the planet. And obviously what we were just talking about is really keeping people safe. But Erika, probably yours, we associate more medicine often with, you know, helping people, help the people, which obviously it does. And Erika, I know there are a number of biology majors in the audience, as well as some high school students that are probably interested in this. And, you know, you specialize in neurosurgery or neuroscience, you did biology, immunology. And so can you, for our students that may be interested in medical careers, can you maybe give some insights of what are some of the different medical careers, you know, you maybe personally know about, and what qualities you think, you know, maybe most successful, you know, people in those fields have?
Great question. I was going to say, I was getting really into Jonathan's talk too, just because thinking about the West Memphis, Arkansas bridge right now, we're going through here on I-40, huge split in one of the beams. So I have no idea how long that's going to take. That could have been a huge disaster that we've been hearing about for years, right? But just going back to medicine, so yeah, sure, there's interesting a lot of careers in medicine. It doesn't always involve, you know, having to obtain a traditional medical degree or an MD. Or if one has a medical degree, it doesn't always require that that person work directly with patients. Healthcare, which honestly I can appreciate much more now than I did even when I was taking care of patients, is just really so complex and requires not only an understanding of just the basic biology and anatomy and the science behind, you know, how our bodies work, but it also requires an understanding of, you know, behavior and how socioeconomic factors affect our health and our ability to take care of ourselves. You know, it also requires an understanding of, you know, the business of medicine, because there are so many middlemen, you know, in between a patient and how they access tools that help prevent and diagnose and treat diseases. So there's a whole business to medicine that honestly, as a physician, when you're in training, you don't get exposure to whatsoever. We don't understand anything about the business of medicine until we're done with training. And now all of a sudden we're pushed into having our own businesses as private practices. And that's when we start learning as we go along what it takes to have a successful practice of medicine. And you really learn hard lessons along the way. So there's so many different, I think, careers in medicine, just in general terms. And as we've seen, you know, recently, technology and medical innovations are vital to medicine. So healthcare providers are often important in just participating in the discoveries of new ways to manage, you know, a patient's health and well-being. So, yeah, I mean, just thinking about, you know, our vaccines that we have and how quickly those were kind of like studied and on the market. I mean, that would not have happened without the help of healthcare providers. So, these are very, very diverse set of careers. I would say, even just in the neurosurgical space, there are a number of different types of neurosurgeons. You can be a general neurosurgeon and kind of do a little bit of everything, just like a general surgeon does, but you could also be very highly specialized. My interest is in skull base and brain tumors, but there are skull-based vascular surgeons who clip aneurysms. There are just interventional neurosurgeons who treat strokes. And, there's spine neurosurgeons who only do spine. So it's such a huge, huge, diverse group of careers, which is what I love about medicine. In terms of being happy, that's such a cute term there. I would say I come from a surgical background, and I'll be honest with you, it's a difficult road to maintain your well-being. A lot of times we're working, 15 hours a day, oftentimes, which, it takes you away from your families. It takes you away from just caring for yourself in general. So I think some of the happiest surgeons and physicians in general are those who are able to set boundaries for themselves and knowing what you are or are not willing to kind of sacrifice for your career. If you understand that, even if there are side effects or repercussions for the decisions that you make in maintaining your boundaries, which there will be, that's 100% guaranteed. But you can be more prepared for how to move, forward. What I love about neurosurgery is that, were my patients I served, doing procedures that were life-saving, the complexities of the brain, the room for technology, all of the unmet needs that are in the space of neurosurgery. What I didn't necessarily love was how unrealistic expectations we put on physicians. We're all humans. We all need certain things just like any other human does. We may be able to do, without it for a little bit longer period of time. Like, again, 15-hour surgeries, I may not have to eat as much as someone else, or I may be able to go a little bit longer without sleep, but we all need those basic things that everyone else needs. And I think this pandemic really showed how much pressure are put on people who are in the healthcare system and how human we really are. So I think just being able to understand what your boundaries are up front will make you just so much of a happier person. So.
I love that. And I love that idea of needing to understand yourself. And that's actually one of the things we're going to be talking with the students about next week is about that. So Erika, I want to talk to you about entrepreneurship, but we're also running near to time. So if you're willing, we might actually come back and ask you about that at the end. So any student interested, it's really interesting what she's doing on the entrepreneur side. So people, please stay to the end of that. But I want to kind of switch over to the next career track, which is green energy. And hear from Joe. I think when we say green energy, people often think, wind and solar, which are important, but as you and I have talked, there's just so much more to green energy than in careers in green energy than just those two fields. So can you maybe just talk about, careers in green energy, both solar, wind, and other areas?
Okay, I'm sorry. I was trying to be quiet. So, yeah, there are many, people ask me all the time about green energy, and they assume it's wind or solar or something with hydrogen or, and to me, there's energy that you use, and then there's energy that you choose not to consume. So to me, a very broad definition of green energy is, for instance, I told you today, I came in where I'm building a very energy efficient house. I will cut the electrical and the energy use in that house of gas and everything by 50 or 60%. And that'll be for a lifetime. So anything that reduces your carbon footprint. A lot of my background is in building and how buildings behave. Insulation is important, but you will learn if you take a BPI course, a Builders Performance Institute course, or a HERS rating course, that it's not all about insulation. It's how tight a building is. And so what's going to happen in the future and in these students' lifetime is you will see the building codes tighten up so much that you will have to put an energy recovery ventilator in every house in order for you to have good air to breathe. Matter of fact, I'm selling my house now. I'm building me a zero energy house next year. and I will get my fresh air in through a coil that brings fresh air in and takes the bad air out while I bring the good air in. And that way I don't lose a lot of energy. So changing lights out. Sometimes I'll go in a factory and I'll change out lights and put in LED lighting. And LED lights, new LED lights, cut your energy consumption by a factor of 8 to 12, depending on how you do it. So there are just a lot of things that make up green energy. And now we are actually taking solar and making what they call green hydrogen out of it. So anything that cuts energy use or produces energy a new way, a renewable way, to me is green energy. And like I say, it's just unlimited in the construction trades, in the electrical trades, solar, wind, hydro, micro hydro. I've done a few micro hydro systems where we take water out of a stream and divert it and put it in the little micro hydro and turn it back out. As a matter of fact, I'm on the foundation board for the White's Mill Foundation, which is a mill that we've brought back to life, that we grind flour and meal using water power. And so when I was much younger, there was a fish pond there, and I'm going to take a fish pond from the community college where I teach. I'm going to take a micro hydro from community college where I work now, and we're going to install that, and we're going to actually put the trout back in the pond, so that micro hydro, as it discharges the water, we have a cold stream, and it creates oxygen so that we can keep the trout alive. So we're going to bring that back. So it's unlimited. The type of things you need to know for green energy. I'll take it all the way back to a BTU, because everything ultimately becomes a British thermal unit. And so a lot of times when I'm comparing efficiencies and comparing energy things, I go all the way back, whether it's natural gas or propane or electricity, whatever, and I take it back to BTU values and look at efficiency. So it's just wide open. It's only limited by how much you think about it. There's just so many avenues out here in the future in green energy. I will tell you that in the United States, I've been really fortunate. I've traveled over a lot of the world. I've been to like 5 foreign countries in the last 4 years. One of the things that we fight in the United States, in a lot of ways, our energy is too cheap. We waste a lot of it. If you go in any developed country, anywhere else in the world, you will find much higher energy rates. Doesn't matter if it's Germany, doesn't matter if it's Greece, it doesn't matter if it's one of the Caribbean islands. We are just blessed with cheap natural gas, and we're blessed by having cheap electricity. Now, most of the electricity in America, just in 5 years, for instance, we have gone from 50 to 60% of the electrical energy being generated by coal to now coal has dropped down to like number 2 or 3. So where I live right now, we're actually producing our energy with natural gas. And that has all kinds of implications because, as you may know, we are taking natural gas, we're compressing it and sending it to foreign countries. And we're not just doing that now at 1 or 2 ports, we're doing that at 4 or 5 ports. So you don't have to be a rocket scientist to understand that even though we have a lot of natural gas prices are going to go up. When natural gas prices go up and you're tied to that to produce your electricity, what's going to happen to electricity rates? They're going to go up. Now that helps me, that story right there helps me sell solar. So I've gotten pretty good at telling that story. But if you're in America and you think that you're just going to be able to live on these cheap natural gas prices and cheap electricity prices for the next 30 years, there's going to be a great awakening in your life, because it's not going to happen.
Thanks, Joe. That was really good. I'd like to do something a little different now, and we're running close out of time, but we'd like to give the opportunity for the students to vote on a question. So if we could actually have question come up that we're really going to give the students the opportunity to vote. On which question would you like us to answer next? What type of different disciplines do you work with inside or outside your organization, or what skills have been most important to your career? So we'll give everyone and it looks like the students want to hear about what skills have been most important to your career. So we're running out of time. So maybe if people can just say what kind of a short, what are then the one or two skill that's been most important to your career. Erika, do you want to start? Just what one or two career items have been most important to your career skills?
It's interesting. I think these are just skill sets in general. But for medicine, I think perseverance is just one. Understanding that, no does not mean that you are not supposed to be doing something. It just means that there are other avenues at getting to the final goal that you're trying to reach. Flexibility, I think is another one. There's no room for kind of like being set in your ways in medicine, because there's so many different people who are involved in healthcare that you really have to be flexible with everyone's job and allowing things to move smoothly. So being able to be flexible, I think, is really key to having a good, efficient strategy of providing care for patients. I know those aren't like technical
I love it.
skills, but those are they're really important.
Yeah, perseverance and flexibility. Jonathan, what two skills do you think are most important?
Yeah, I just kind of echo that, Erika's. I do think the other technical skills are going to come. You'll most likely need to relearn a lot of things on the job anyway. So I would say that some of the soft skills that they don't teach in college are actually the most important. Some of the ones that come to mind, I guess, increasing your emotional intelligence, learning how to read people, how to communicate with other people, how to communicate your thoughts in an effective way. And then for me, self-awareness has become much more important, like knowing yourself better, how you operate, because you ultimately know yourself the best. And if the environment that you're in is not conducive to your best work, then it's up to you to be able to tweak certain things, or that kind of ties into being able to work with other people and to communicate, just knowing how you come off to other people, how you represent yourself. And then I would say those two are the most important.
Great, I love it. Allison.
Yeah, I would agree with all those. One I would add is critical thinking skills. I know my engineering studies really helped me hone this, and I use it all the time. And what I mean by that is, just to boil it down, is the ability to assess a problem and come up with actionable solutions for it. Is really a skill set that you'll use time and time again.
Great. And Joe?
I absolutely agree with all of those. The one thing that has helped me in life is when I was very young, I pumped a lot of gas and served a lot of sandwiches. We had a small business. So when my schoolmates were meeting 5 new people a week, I was meeting 100 or 200 new people a week. So I say this, and it's kind of a joke, but it's really not. I obtained my greatest education from working behind the counter. And it goes back to what everyone has talked about, those soft skills and being able to read people. I also was raised in a family that never gave up. And I'm one of those, the only way you're going to defeat me is to kill me. I'm never going to give up. I've just persevered from day one. But being able to meet people and greet people and remembering people and taking just a couple of minutes sometimes to ask about someone's family and ask what someone does. for a living, because you may need that person next week, next year, or 10 years from now. And if you build up those relationships, it's a lot of life is about showing up and networking with people. And I'm not talking about networking in an electronic sense. I'm talking about just talking to people, learning what they do, so that you may need to ask for advice, or you may need that person to deliver a service to you at some point. So networking is so important. And we talk very little about that in education and in engineering schools and other things. And it's really, really important skill set.
Yeah, I love all those answers. And I think ending the session with Joe with the networking ties it back to Elisa at the beginning, saying that we got Allison through the networking. We're going to have a whole week. Our week 4 is just on networking and talking stuff like that. So I love that. We try to keep this under an hour, but I know some students really want to hear about the entrepreneurship. Probably students want to hear from other panels also. So for those students that want to stay on, Erika, can you stay a couple minutes? And actually the rest of the panelists, if you're willing to stay a couple minutes, we can open up to the students, but I want to, in a sense, be sensitive to people's times, and if they need to go, again, thank you. We'll give a silent round of applause to all the panelists again. We really appreciate that. And again, if people want to stay on, we welcome to stay on, but we recognize some people may need to leave. And with that, Erika, we talked about you being an entrepreneur. How did that come about? What lessons have you learned? If you can just kind of tell us a little about that.
So this is where I guess that kind of perseverance and flexibility kicks in. Again, this has not been the straight and narrow road from high school to undergrad to medical school and grad school to residency and career. I've had to make a lot of adjustments along the way. My being here was really not that voluntary. I was in a surgical program that I wasn't happy in, and that particular training environment. And so early on, I started to recognize that, but it wasn't until my 5th year that I started to seek out other opportunities in terms of neurosurgery, and came in contact with a different neurosurgeon who worked in the same city as I was in, who had agreed for me to be working with him to do a kind of like a fellowship program. And interesting, 1 week before I was supposed to start that opportunity, I had done all the training and everything. The whole hospital closed. I mean, like literally, for major patients in the city of Philadelphia, closed the week before I was supposed to start. And which, I never would have been able to predict something like that happening. So I was really forced very quickly to figure out something else that I do. And as I was mentioning before, this opportunity for this fellowship kind of just landed in my lap. I was going through that process at the other hospital and saw this email as I was doing my training. And when that happened, I went back to that email and said, wow, this seems like a really interesting opportunity that just happens to be available for me right now at a very moment when I actually really need to figure out what I'm going to do next. Or in the next couple of years while I have this time period. And a fellowship called Patents to Products in Memphis, Tennessee, at University of Memphis, that teaches people who have science backgrounds how to commercialize intellectual property and essentially get paid to do so. So I jumped at the bit to apply to the program. I always imagined that I would be kind of like involved in creating new technologies, but I didn't think that I would be the CEO of a company. Number one, I didn't think that I would be the head guy. I figured I would probably maybe at some point in my career, be a consultant for companies who are doing innovative technologies in the healthcare space, or maybe be a CMO, a chief medical officer, an advisor for a company. But here I am as the CEO of my own company for a technology that I developed myself and am commercializing myself. And so I love it. And I never knew that I would love something like this. And it's required me to kind of push my trained way of thinking as like a physician, especially surrounding risk taking. In medicine, it's about following a protocol and not really veering from that. Or if you take risks in medicine, if a risk is necessary, that should be a calculated risk, and there should be benefits that outweigh that risk. And there's obvious reasons for that, right? Because if the more you take risks, the more a patient's life is at stake for that, for the decisions that you make. But in business, it's all about taking risks. I mean, I have a startup company, and if I'm not taking risks, I'm probably not going to see the return that I like to see and establish in my own business. So I didn't have anyone specifically in my immediate family growing up that were entrepreneurs. I had kind of like distant cousins who had businesses that were very successful for them, but not someone that I could see, every day that was doing that. My mom worked for the US Army, and talk about protocol, like, there was no risk taking there. My stepfather was a journalist. So my exposure, even, to medicine was much later, in later stage in life, was actually after, I graduated, or actually right before I graduated undergrad. So and then after, my training, the physicians that I saw that were entrepreneurs, most had been practicing for, a number of years before they even decided to try their hand in entrepreneurship. So, these were things that just really, again, like I said, life has a really interesting way of bringing you back to things that are passions for you and things that you're naturally, inherently good at, and utilizing those for the better of the world, and so that's how I ended up in entrepreneurship. My company is called PopCheck Technologies. We're creating AI-driven remote monitoring technology that helps predict when patients are developing postoperative complications. And as a first stab at that, we're looking at predicting the development of venous clots. So clots that develop in a patient's leg after they have a surgical procedure, very high risk for certain types of procedures. But no way of determining whether or not a patient is developing those, except for just being admitted to the hospital in the emergency room and having an imaging study. So that's kind of what led me to what I'm doing.
Yeah, that's really interesting. And that's interesting, kind of the dichotomy about, the different professions. So that is great. I really I learned a lot. I thought it was really interesting. Really appreciate it. I know the students, I'm sure, did also. What we're going to start doing a little differently for the students is those who want to stay behind and maybe just talk informally about what we just learned and heard about. We're going to give you that opportunity to do that, to maybe get us to know each other. But Allison and Erika and I know Jonathan and Joe had to go. We just really appreciate your time. We know how busy it is, and this was our first session, and probably saw I had little internet connection problems, but I really appreciate you. Your time and letting us learn a little more about you guys. So thank you. And
Thank you so much, and good luck to all the students.
Yes, thank you for having us. We appreciate it. And anytime you guys have questions, feel free to reach out.
That'd be fantastic. I'm sure a lot of students will appreciate that. So thank you.